Hello. In this video, we will be introducing numerical method. Okay. So, these are the things to know for numerical method. Uh, there are three phases of engineering problems. The mathematical background, the mathematical model, the programs and the softwares that use in numerical method, uh, the truncation, error and Taylor series, and approximation and round off errors. So first would be the three phases of engineering problem. So in the figures that you can see, we have letter A as the pre-computer era and letter B as the computer era. So the sizes of the boxes indicate the level of emphasis directed toward each phase. So computer facilitate the implementation of solution techniques and thus allow more emphasis to be placed on the creative aspect of problem formulation and interpretation of result. So in the free computer era, it's kind of how you solve is the solution phase is kind of a longer stage no in the problem solving in the engineering problem solving no because you really need a mathematical skill in order to have the data that you need while for the computer era it's kinda it's the solutions of how we solve out from the mathematical equation, the mathematical model that we created, is kinda simplified, to which uh, how, how we simplified it can be computer calculated. It could be easier to solve because we have a support in computers, and the output out from that computers will be easily interpreted and thus have more time to really dig in with the results, try to yeah to see the graphs out from the computers, more time to really understand the results. So that's the difference. So it's kind of the same in every stage, but in formulation, it's kind of how you create the problem, how you create the mathematical equation. It's kind of the same. So, however, the different thing with computer era is that those equations that had been created will be translated onto an equation that could easily be input into a computer. So there is kind of additional hours also in formulation because the equations that we learn from the sciences will be translated into something that could be easily input into computers. So more likely like that. And also in solutions, so in pre-computer era, we need to know calculus, we need to know differential equations, we need to know some statistics, statistical method, lots of stuffs that you really need to know in order to solve the mathematical equation or the mathematical model. However, in computer era, solutions for statistics, so we have Excel, we have softwares that could do for your calculations. So it's kind of there is an easy it's kind of an easy way, and also it kind of saves the time in calculation. And also the generation today is that we have a very powerful CPU. They already talk about how many cores, how many calculations that it can do for your computers, for your cell phones, for your laptop. So yeah, we need to be useful, and we need to use that kind of advantage, to really just shortens time of the the yeah, in solving engineering problems. So as I've said, in the engineering problems, we need to, yeah, formulate the mathematical model or the mathematical equations out from the problem that we observe. Uh, so these are some of the, yeah, now some of the mostly the equations that we need to formulate. So first one would be the recursive equation. So we try to find the x of the function in which it is equals to 0. So first we need to define what is the recursive equation, and yeah, in which in recursive equation we try to use algebraic skills in order to solve the x. So in this time, we will introduce many methods so that you could solve for the x, you get the value of x. Then B, the part 3, would be the linear algebraic equations. So this will be the given the A's and the C's to solve for the X's. So it's basically multiple equations with multiple unknowns, finding the value of x in which the lines intersected, no, if you can see it in the graph. So those are the multiple roots in a multiple equation. Next one would be optimization. So that will determine the x that gives the optimum function, which most probably the finding the minima and the maxima. Then curve fitting. So for curve fitting, this is most probably using statistical tools and using linear regression and nonlinear regression. So to create an equation. So out from the initial data, um, it kinda have a, yeah, you have data but you don't know how to interpret it with it. So you kinda use statistics, kinda use the regression in order to have a predictions, to have a graph presentation in order for which you can fully understand what is happening with your data. Then next would be integration and differentiation. So yeah, so in integral calculus and differential calculus, there are matters that you familiarize the differentiation formulas and integration formulas. But in numerical method, yeah, we will be not using that, but instead there will be new formulas. Yeah, it will be lesser formulas compared to the traditional one, which you could also solve for the you could also integrate and differentiate an equation. Then next one would be solving ODEs. So again, new methods will be used. So the Euler method, the RK, the Runge-Kutta method. So kung traditional, we might be using MOSOV, so method of separation of variables. Yeah, there are also ODE formulas. There are also characteristic of ODEs you need to learn before solving the ODEs. Then last part would be the PDE, the partial differential equations, for which again new formulas will be introduced and yeah, kind of replace the traditional method that we use. So all of these uh, parts in numerical method will be introduced to you know, and here we are not trying to yeah we're not we are trying to understand the algorithms of the methods. So we try it in yeah, you could do it in traditional way and computer way. It's kind of which uh, the traditional way is kind of hassle because you are writing many tables. No, the computer way is much easier. So, but yeah, uh, later times there the computers are humans man. No, there are no such thing as laptops, PCs at that time. So they're doing numerical calculations. So karon computers are now I know the computers are now the PCs in which they do now the numerical calculations. So yeah. Then we proceed. So these are the phases of the engineering problem solving process. So we have the problem definition again. So we engineers try to detect what is the problem. We try to observe in the situation in a way that we kind of detect the problem, and out of the problem that we knew, we try to relate that into the theories and data that we get on our on what we learn based on the sciences, based on physics, based on the theories and our practices in civil, in mechanical, in IEs, in computers, in EE, and in ECE. So out of the theories that we learn from that specific fields, so we try and relate that to the problem that we detected. So theories introduce formulas or equations, and that equation will be combined with the problem that we detected to create a mathematical model. Uh, yeah, it may be sometime that we do need the data to create an equation. And maybe sometime that we don't actually need the initial data because the equation itself is already been implemented, already been there because uh, there are whole centuries studied in that uh, particular engineering application. So yeah, kind of just declare what is the equation because that is the application based on the application. No? Then after which mathematical model after that. So you need to solve the equation. You need to solve the mathematical equation, the mathematical model, using computers, using statistics, using numerical methods, using graphics. So you could use traditional way of numerical of computing using just your using pen and paper. You could also use computers. You could use softwares. So after that, you already have an output data for which you could translate it into a graphical result. Contour plots, distributions of heat of the model. So from warm to cool or from hotter to cooler region. So it's kind of like that. So or in graphs, you could see rise and ups of uh, specific variables that you use, so just like that. So when you have this kind of presentations, it kind of you could have your own interpretation with it. Uh, yeah, because you're kind of you kind of expert